Okay, well, welcome everybody to Solar Noon Tuesday. And as a reminder for folks who are new to this, what we're going to be doing here is we're going to be recapping what's happening in the news in the solar industry for this week. Then we'll touch on some of the events, some of the webinars, things like that that are happening over the coming weeks and months. And then we go into a deep dive on a specific topic. We hold these every Tuesday at noon, Solar Noon Tuesday, Eastern Time. And this topic this week is going to be about our project that we worked on a week ago or so, a solar carport, solar pavilion type project down at Eastern West Virginia Community College. So I'll jump right in here with the news for the week of May 12th. And the energy industry administration is projecting that I'm gonna change a little bit here so I can actually read it. Yeah, they're projecting that over the next year, U.S. is going to grow in generating capacity about 2%, electrical generating capacity, and in 2025 about another 1%. Now, my concern is that this may or may not be enough. What we've seen over the last couple of decades is fairly steady demand growth, steady demand on the grid. And what's happened is any potential growth has been offset with efficiencies, with LED lighting and energy efficient appliances. But all that's about to change. Now, some of the things we've discussed here in this session, talking about, for instance, Goldman Sachs is projecting that data centers are going to have a huge increase in demand. They currently use about 3% of all of the electricity that's consumed on the grid. That's going to triple over the next 5 to 6 years, especially as artificial intelligence applications begin to be integrated into our world, into our life, and those take a huge amount of data processing and a lot of electricity. Then, of course, we're in the middle of a transition to electric vehicles, and that's going to place huge strains on the grid. We're anticipating that by 2030, there'll be about 42 million EVs on the roads here in the US. That's going to represent about 60% of all of the sales, new car sales happening there. And all this is happening at the same time that we're retiring coal power plants at an increasing rate. There are only about 217 coal power plants operating in the US today. Most of those will be retired by the year 2030. Coal will go down to less than 10% of the generating capacity on the grid. On the one hand, that's great, but we're also seeing a lot of delays in bringing online new systems, sometimes as much as 5 years for permitting for these utility scale solar systems. So it just feels to me anyway that there's this massive convergence of increased demand, decreasing supply, and increasing volatility of weather events and things like that. So we may be in for some big surprises. The EIA projects that new energy sources will primarily come from wind and solar. Solar is projected to grow 75% over the next 2 years, according to their projections. And just a little word to the wise, EIA has always been very conservative when it comes to renewable energy, and they've undershot projections pretty much right along the line. Even though these growth projections are pretty substantial, and it has been impressive here in the U.S., at 22% of our grid capacity coming from renewables, the U.S. is lagging far behind the rest of the world. In fact, they just announced this week the new report from the Energy Institute is that worldwide, 30% of all of the electricity comes from renewable sources. So hydro is far and away the leading source of clean energy on the grid. But wind and solar is growing very quickly. Some nations, such as Ethiopia, Bhutan, Nepal, Paraguay, Norway, they get almost 100% of all of their electricity from hydro. Canada, our polite neighbor to the north there, gets about 60% of its power from hydro. And the study found that 102 nations around the world get more than 30% of their power from renewables. 69 countries get more than half from renewables. And the US ranks 126th amongst nations in the percent we get from renewables, and pretty much last amongst all of the first world industrial nations. So good on us. We're number 126, but we try harder. Right. The global renewable hit 30%. The new analysis from the energy think tank Ember is showing that solar is actually a technology that's growing faster than any other energy technology in history. So what they did, well, we've gone through a number of energy transitions in the past. For example, we went from whale oil to kerosene to natural gas to electricity when it came to lighting. We went from horse and buggy to steam to electric to gasoline back to electric when it comes to transportation. It's just that we're going through another transition, but it's happening at a much faster pace. So this analysis looked at, and I'll apologize for my graphic here. I show 10 years, but it should be 8 years. The analysis looked at how long it took to go from 100 terawatt hours of annual electrical generation to 1,000 terawatts. So a factor there, 10 times. For hydro, it took 39 years to increase that capacity from 100 to 1,000. Coal, it took 32 years. Natural gas, 28 years. Nuclear took 12 years. Wind took 12 years. And now solar is taking 8 years to transition. So really from 2013 to 2021, we had a magnitude of, 10 times in the growth of solar. So it's being adopted very quickly. Speaking of adopting solar, Vermont has just passed House Bill 289, which mandates that 100% of their electricity will come from renewables. And it's doubling the amount that comes from in-state solar that utilities have to get there. The RPS, it modifies their RPS that was adopted in 2015, that it set their renewable goal at 75% by 2032 and had a 10% in-state solar. So they're the latest nation that's gone to the nation of Vermont, the latest state that's gone to 100% renewable. And you may have heard Tesla stock is taking a beating and their sales are down. They're hitting a bit of a rough patch, but while Tesla is struggling, the rest of the EV market here in the US is doing pretty well. Tesla still dominates. They have the number 1 and number 2 selling EVs. But for example, Ford, their EV sales have increased 97% year on year in the first quarter. Sales are also up for Rivian, Hyundai, Mercedes, BMW, Kia, Cadillac. All of their EV sales are increasing while Tesla's are falling off. Tesla's number 1 and number 2, as I mentioned. Their Model Y is number 1, their Model 3, number 2. In third place is Ford's Mustang Mach-E. That's the third best-selling EV in the US. The Rivian R1S is number 4. The Ford F-150 Lightning is number 5, and the Chevy Bolt is number 6. That's the US sales. Now, worldwide, EV sales are pretty much dominated by China and Germany, with the exception of Tesla thrown in there. Chinese manufacturer BYD is the largest selling manufacturer of EVs. They surpassed Tesla in 2022, and in 2023 have actually sold 1 million more vehicles than Tesla did. Tesla's in second place. A distant third is BMW, followed closely by Chinese manufacturer GAC Aion. I think it's AION. I don't know how you pronounce that. Volkswagen, number 5, and in number 6 is another Chinese company, Wuling Motors. So I think we're about to see China become a dominant player worldwide. We're already seeing it in the EV marketplace for vehicles. And that's the news from the solar industry. Anybody have anything else they want to add to the mix here? I know before we started, Chris, you had something that you had just run across.
Yeah, I just read in the news this morning that Biden's putting new tariffs on all panels and chips and other things coming from China.
Uh-huh. So does anybody have any further, any details on that, what that means? Because that's something new. I didn't check the news today.
It's covered well in all the major outlets, including the New York Times. If you want, I can put a link in the chat to one of the it's one of the articles that covers it.
What are these new tariffs, or are they enforcement of old tariffs?
It's basically doubling of existing tariffs.
Really, to 50%?
Yep, I'll get the link and I'll put it up in the.
Whoa, that's going to be pretty dramatic, because I know that there have been some articles recently. There is a 10% tax break for domestically manufactured solar panels and products. That's part of the Inflation Reduction Act. There's been some discussion saying, is that going to be of any use at all? Now, we are seeing a lot of domestic manufacturing taking place, beginning to ramp up. But if China continues to dump solar panels on the marketplace, there's not a 10%, there's a greater than 10% difference. So yeah, you get a 10% bump for putting in solar panels domestically that are manufactured domestically, but maybe 30 or 40% less for Chinese panels. So it may be an effort there to
Here's the quote out of today's article. The rate of Chinese solar cells will double to 50%. The rate on certain advanced batteries, along with critical minerals needed to build them, will raise to 25%. Semiconductor tariffs will double to 50%, and some of those increases will be delayed in a apparent effort to allow domestic companies time to ramp up their own production and find other sources outside of China.
Well, that is dramatic. So that's definitely, I'm glad you guys raised that here, because that's going to be huge impact on the solar industry for sure. I know in anticipation of some of these tariffs, there have been a lot of stockpiling of solar panels here in the US. But this is definitely going to have an increased cost. We should bear in mind, though, that the components of an installation are really only a third to a half at the maximum of the total cost of your install. And solar panels are about a third of that cost. So an increase in cost of solar panels, it's not like the cost of your solar array is going to double. It's doubling of 1/6 of the cost. So it will have an impact, but it's not as perhaps dramatic as it sounds initially. All right, well, let me jump into some of the announcements of events that are happening over the coming few weeks here. We've got a session May 15th, DC fast chargers. And I'll remind you that that these are, I don't have the links here. If you need them, you can contact me, but I'm just making you aware of these because there's this thing called Google and you can just find them. That's an easy process there. Then May 16th, financing energy storage. They're focusing a lot on long-term storage. So that can be a big deal as far as getting the financing on those things. Selling solar in 2024. This is another May 16th at 2 p.m. Webinars coming up on May 16th. Growing the green workforce. This is from IREC, and these things tend to be sort of work group discussion type events. I know I've been involved in a couple of them in the past. So not really a passive webinar, but more like something they're going to ask you to participate in. The ACES conference is happening next week. I'm going to be there in Washington, D.C., which is the only reason you'd ever show up, no doubt. But no, there's a lot of activity going on there. So if you're going to be in Washington, it's at George Washington University. So I invite you to attend there. There's another virtual conference put on by Aurora Solar on June 5th and 6th. That's hanging out there. June 13th and 12th, 12th and 13th, Solar and Storage Summit in San Francisco. And then there's another face-to-face, July 18th and 19th in Philadelphia. And then I thought I'd throw in here too, there's an interesting publication from Solar Builder talking about how to maximize home battery investments. So if you go to their website, you can download their white paper on that. More and more people are installing batteries into their residential and commercial systems. So good research, good background information for that. And our shameless plug for our own courses on solarpvtraining.com. Those are there face-to-face and in person, so you can find those. Does anybody else have anything they want to add to the list of upcoming events?
I have a question, not necessarily about events, but speaking about battery backup. Are you planning, perchance, having a special course, online course that we could take? Your basic course covers some of that, but I thought maybe you were planning on something more to the point.
Yeah, I know we're in the process. In June, we'll be releasing the latest edition, the 9th edition of the Understanding Photovoltaics textbook, which is the basic residential textbook. And we did a lot of updating on battery technology in that book because batteries are becoming more and more of a thing. Another thing, we de-emphasized lead acid batteries and talked a lot more about lithium ion batteries and all of the battery management systems. I think we do a pretty good basic overview there. I have a feeling a lot of what you're looking for is going to be very proprietary because these lithium ion batteries all have incorporated management systems built into them. So some of it is how do you control those? How do you program those? Everything is getting to be more computerized and I like to joke that it takes 2 days to install a system anymore and a week to get it to actually communicate and function. So we're becoming computer programmers more than electrical installers with these things. So I know that there's some battery certifications. NABCEP has a new battery certification that's out there. But I don't see myself putting together a targeted course on that unless we just simply pull out what's in our existing courses and kind of package it as a short course for batteries. I'm feeling overwhelmed with stuff as it is. I can't see doing that. So I'll send you to do that, Al. You can make a course for us. So, yep. Our goal is, I think our next big project, we're upgrading the residential. That's all going to be rolling out this year with the new textbook, then the new online courses and the new support things for community colleges and things like that. Then we're going to be updating the level 2, the commercial program. So that will all be done 2025. At the same time, we're hoping to then get these things translated into Spanish, so that those are available out there. I'm hoping that artificial intelligence will make that life a little bit easier. And I thought I saw Pat earlier when we were just getting started that I know there's a process when I'm mentioning translations. Pat, did you want to mention about the Ukrainian project? If you're online, can you jump in? I didn't warn you on this.
That's okay. Thank you very much. Yes, I sent you a few interesting things today. My name's Pat Strong. I'm working on a grant project with the University of Kharkiv and the University of Chernihiv, Ukraine. We are setting up a solar workforce development program. The solar industry is pretty advanced in Ukraine, but they're under incredible strain, as you can imagine. So I think what I sent you today, Jay, is that we have a very small fundraiser going on now for a partner of ours at Kharkiv University who doesn't have stable internet and stable electricity. So we have a small fundraiser going on because we're shipping them 24 large solar panels so that they can construct kind of like a classroom bomb shelter, if you will. The grid is often down, and So I provided the LinkedIn profile of Ksenia Minikova, who's a solar engineer there that we're working with. So that's the first thing. The link is in your email. And then our longer term project is that we are setting up a year-long project for Ukrainian veterans to show them the spectrum of jobs available in the solar industry. I think when I first started the project, people said, "What? You spend a few days and then you're up on the roof, right? That's it." And so we're getting the academics involved to say, well, yes, you can be up on a roof after 3 days or something as an apprentice or a helper, but there's so many other jobs and careers in solar. So we're having a great experience with solar companies in Ukraine, and we're actually fundraising for that project. So these are things I can update you on as time goes by.
Okay, well, great. That's good. There's so many interesting things going on in the world of solar at the moment. I'm working on a project where we're doing a workforce development in the Ohio prison system, setting up training labs within the prisons to try and get people careers when they get out. We're doing another project here in Appalachia where we're calling it solar on a pole or polar solar or whatever, but it's kind of an interesting little project where we're doing a 12 panels freestanding mount with end phase systems so that we can come into these rural homes that may or may not have internet, and put in solar without having to then essentially penetrate the shell of the home. So this is kind of a project where we're looking at changing out the meter box and putting in a disconnect switch there so that it's up to code. So then we can hook the system directly into that meter box without having to go into their service panel to make the connection. So everything's outside, everything's connected, and then it'll communicate through the cellular modem in case these homes don't have Wi-Fi or whatever. So we're just, there's a group that's got a grant or in the process of getting a grant for 75, possibly 150 homes to get this going on. And then another project we were working on was taking damaged solar panels from utility scale systems and testing them to see just kind of what production we can get out of those. There are hundreds and hundreds, and I'm sure tens of thousands of these panels that are just thrown away. And if there's a way of using them, the lightly damaged solar panels, ones that are cracked, but not cracked to the, not leaking, not cracked to the outside of the unit. I don't know if they're going to produce 90%, 95%, 50%. That's what we're going to be testing is how well those things are going to be producing. So those are just a few of the projects that are floating around at the moment. Before I jump into our latest build here, anybody else want to throw anything into the mix here while we're chatting?
I can tell you I had a huge snow load fall on top of some temporary solar panels that completely shattered the glass, and they still produced. They're not great. I have a whole bunch of them. If somebody wants a whole bunch of solar panels, I'd be happy to give them to you. But they were still non-zero. I mean, some of them were low, but some of them were still 60, 70%. It was really surprising. And by the way, please don't do ground-mounted solar right under the eaves of your barn in Wisconsin. It's not a good idea.
Okay, that sounds good. It's a major league hailstorm happening all at once, right?
Yeah.
Yep. Okay, well, let me jump into the project that I wanted to talk about this week. Just to give you a little bit of background here, I've been doing some consulting work with the Eastern West Virginia Community and Technical College down in Moorfield, West Virginia, to give you a sense of where that is. It's closer to Washington, D.C. than it is to me. It's just over. In fact, you got to go through Maryland to get there from here. So this is the concept anyway. And what we're doing, it's part of their solar training facility. So we did an indoor lab with the various labs where we're doing a microinverter system and a solar edge and a string inverter for the wiring and the like. And then there's a hybrid with wind and solar. But this is an outdoor pavilion, and it's serving two purposes. The main purpose is to be a lab that the students can disconnect, work with. It's also got, they're going to be putting some picnic tables in there, I think, and there's some outlets. It's a standalone system, so they can plug in, recharge their computers. And then I'll show you a picture later, but there's a big flag next to it, and they wanted to hook up some spotlights to highlight the flag. So it's kind of a 5 kW system to run a spotlight for a flag, which is a little bit overkill, but well, a lot overkill. But anyway, it was a fun project in some respects and a frustrating project in other respects. But I just thought I'd walk through what we did and maybe get some input from some other folks as to what we did wrong, and maybe somebody can tell me how I can get the system commissioned here in the not too distant future. So what did we install on that pad? Well, we put in a 5 kW 48 volt Sol-Ark inverter. It's 120 volts, so it's not the 240. It's their low end cabin type system. There's a HomeGrid 5 kW lithium ion battery pack that goes with that. We used IronRidge racking, and they're 12 395 watt JA solar panels, so 4.7 kW DC. So that's the components writ large there. So the first step was to essentially design the racking system. So I used IronRidge for this, and IronRidge has a nice online design tool. Most of the racking systems are going to have something similar. I've just gotten in the habit of using IronRidge, but I know there are others, and folks, it's, you like what you like or you use what you use. IronRidge used to be one of the do-it-yourselfer cheapy types. Now it's not so cheap, and I don't know how much do-it-yourself it is, but anyway, it's got a nice design tool. So after you go in there, it'll give you your specs. So we decided to go with 3-inch piping for the piers. The way that IronRidge does that is they'll spec out all of the parts, but you got to buy the pipes, the support pipes locally, which can be difficult, especially when you're talking about the 3-inch stuff. Finding a good supplier at a price that's not going to just send you screaming and crying is tough. This particular system, we designed it in 3 columns, 4 rows. So it's 12 panels. And you can just see that the area that it gives is 17 foot by 15 foot 2 inches. So that's there. The east-west pier spacing, 12 foot 8. So this is the nice thing, and this is why I do this first, is it's going to give us our supports. It's going to tell us where everything is. Because the first question that the folks asked at the college was, how big of a concrete pad do we need? So we decided to just simply make it the size of the canopy of the array. So I just told them, based on this, to make it 17 feet wide, 16 feet deep. So that was what we did. Now, you may be installing something like this on an existing pad and you don't need to have that information, but you'll need to know if you can fit the things. IronRidge normally anticipates that you're going to be burying these things in the ground. That shows you there. That picture is just giving you the dimensions, but this is the one I wanted to jump to. This is part of the drawing that you'll get from them, and they're usually anticipating you're going to have this thing pretty low to the ground, and it's going to be buried with the poles going below the frost line. In this case, we determined that it wasn't going to be low to the ground. It was going to be high up so students could use it as a place to sit, a little bit of a shade pavilion out there. and it was going to be on a concrete pad. So that required, this is the second one of these that I've done. So the first time we had to try and figure out just how do you mount this IronRidge system to the pad, because there didn't seem to be any mechanism or anything they sold that was designed for that. So the way that we've addressed that particular issue, excuse me, is the IronRidge system has this little top cap here. That top cap is what sits on top of the pole. And then the cross poles are looped in there by those U-bolts and ratcheted down. So those are designed for the very top. So we called up IronRidge and said, well, is there a problem taking those top caps, turning them upside down, of course, taking out the U-bolts and using those as essentially bottom caps, where you can place the pole in this unit and then simply bolt that unit to the concrete. They informed us that people do that all the time, but they do not, I don't know, they gave us lawyer type talk. You know, their engineers are not going to certify that it will in fact meet all of the conditions, blah, blah, blah. But wink and a nod, yes, everybody does it, you know, that kind of thing. So we've done it, and I have not seen any issues with it at all on the one that we did down here in Marietta. It seems very, very strong, and it survived some wind events and showed no problems there. Yeah, Pete, you got an issue or a question?
Yes. Did you drill a hole in that cap to let the rainwater get out of it so it doesn't burst when it freezes in the winter?
Yes. Yeah, they did. They drilled a hole right in the middle. And if you look at the top, there's this little ridge. It's sort of a receiving area for the pipe. So when you turn it upside down, it's got that little channel that will actually channel water out. So we just drilled right down the middle with just a small hole. So in case water gets in there, it's got a place to escape out of that. So, yep. That was one thing I didn't think about, but some of the guys who were helping out on the site said, hey, you know, we ought to do that. Now you can see here, Jimmy, who was helping out, was a big help on the job. We had marked out the locations for these. We're placing them there on the concrete pad, and then begin to drill down in to set these in place. We used these redhead anchor bolts that go down in. Once you've drilled through the concrete, you pound them in there with a hammer, and it expands out. I don't know if you've used them, you know what I'm talking about. If you don't, they work. That's how we anchored those, 4 of those in each of the units. Then we had to, of course, set the poles. And I'll just warn you that this particular project seemed to want to fight us the whole way. You know, I had originally thought that we could get this thing up in a day and a half, maybe. And I was kind of thinking one full day we should get this thing up. And the second day was sort of, you know, everything takes longer than you think. So let's give ourselves half a day to clean up all this stuff. Anyway, it took 2 full days from 8 in the morning till 8 at night to get this thing in there. And one of the things that we fought was, you see, when you're drilling, the IronRidge has this silly thing where they have these set screws where you're supposed to just sort of tighten them down, and that's supposed to hold the pole in place, which is the dumbest thing I've ever heard of. So we always drill through it and put bolts to hold that thing so that, you know, just not relying on set screws. Well, the way we're drilling into this, you can see here, I think that's Chad who's drilling there. You have to drill a pilot hole through everything first. And we must have broken a half dozen bits, you know, as these very small quarter-inch bits or whatever. And so we went through a few of our bits, and then we drove down to Ace Hardware, which was 30 minutes away, and bought all of the bits they had, and then we broke all of those. So then we had to drive over the mountain, which was 45 minutes away, to get another set of these bits. And so I think I spent about $400 in drill bits, and we finally got the whole thing done. But that was, and that's one of the things where you're working in rural West Virginia on a Saturday and Sunday. Well, all the hardware stores closed at noon on Saturday, and nothing's open on Sunday. So, and everything's an hour away. So you really have to kind of anticipate some of those things. So I come from a rural area, but I was feeling pretty urban, while I was working there. So anyway, that was frustrating. So anyway, then we started cutting the piers and the supports. So we had measured those things out. These are just the 3-inch poles. They're very heavy duty, good support. One of the things I've noticed in recent years is the cost of these things have just gone through the roof. Used to be you could run out and buy one of those poles for $30-$40. Now you're lucky to get them for $110, $115 a piece. So we needed 8 of them for this project, which represented about $1,100 just for those bits of metal, which is absurd. So, but that is what it is, right? So we had to cut some of these using all of our appropriate safety gear. And of course, we had run the power cords. You can see in the far background that little it's the transformer, which is straight back, sort of over that pole in the background. That was the nearest plug. So there was, I'm sure, no voltage drop as we're running those cords, 200 feet. Yeah, I'm sure the cords were pretty hot as we were working on these things. So, but we managed to get through that. And then you can see you start to mount the poles out there on the pavilion. It starts to shape up pretty good, pretty solid. You can see the cross members going there. There's one of the difficulties with this particular project was I've worked with poles before that were threaded, and you could just simply do a coupling, and they're really a nice connection, easy to do. These particular poles are not threaded, so they gave a insert coupling, as a smaller pipe that fits inside. And that required us to drill 4 holes to bolt these things together. And the interior coupling was not exactly tight. So the poles wanted to sag where they were joined. There was maybe 1/8 of an inch of give in that particular coupling, and that was frustrating. So it was we wrapped it in duct tape, to try and tighten it up a little bit, and put in some wedges and the like, and we got it to work. You can see there's not any sag there, but it just takes time. It was annoying. If we had a coupled one, that would be just so much easier. But then, of course, the couplings get in the way when you go to put the rails, because they're always going to be right where you want to mount the rail. Those couplings, it just is inevitable that way. So speaking of mounting the rails, then after you've got those support poles up there, IronRidge uses this little rail mount unit. The 3-inch U-bolt just connects on the pipe, and then those bolts that you can see on the plate fit into that extruded groove in the side of the rail. I think this, if I go one more here, you'll see it where his hand is where that little unit is, and it bolts into that extruded groove there. But then we began to set these rails, and I'm not quite sure what was happening here, but as we were putting the rails up, you know, the IronRidge display will tell you what is the cantilever, you know, how far it is. It turns out it was like 3 feet on each end for the rails. And then you just space them. My rule of thumb with spacing of rails is you come in about 25%, leave about 50%, then the second rail is going to be about 25% from the edge of the next one. So it's not an exact science with this, but that's sort of close. Well, for whatever reason, as we're laying these things out, nothing seemed to square up properly. So we're constantly having to move rails around. I think it was just because we were working with people who had never installed anything before. So it was just, you know, you tell them 6 inches and it might be 6 inches. And then you had to go back and check. So that was one of the realities of just working with a crew that's fresh and new to all of this stuff. So that was a bit challenging. And another thing I wanted to point out here is that this particular, I like to put these little gasketed rubber ends on the poles. Those you can just get at any hardware store, those little hose clamp things that fit over the end. The reason for that is these things will attract bees, hornets, whatever. It's just nice to close those things off as you're doing it. IronRidge doesn't really mention that, but that's your tip, the tip for nothing there for mounting the rails. So as I'm swinging through this thing, anybody have any questions so far on what we did, what we're doing? I'll give you a chance to jump in. Otherwise, I'll get into, yeah, Pete.
There, no, I'm clicked in. I'm not seeing diagonal bracing, and for racking stiffness, I'm only seeing a little less than 1 diameter of engagement in the fittings.
Yeah.
What's your situation for lateral wind moving this around?
Well, these things are pretty secure. You can do diagonal bracing if you want. I did that with our system here at our farm, but mostly because we're running goats in there. And I was worried that they'd be bashing into the poles and causing that. But this thing is engineered without diagonal bracing to deal with the wind shear. You know, and they even say with the set screws. So, and the lift and all of that. So when you do your design, you plug in what is your zip code, and it will actually then set the pier widths, you know, and it factors in snow loading, wind loading, earthquake, seismic loading. All of those things are factored in, and they send you engineered drawings. So if you're doing this in an area where you have to get permitting, you can take those engineered drawings down and get your approval that way. So that's one advantage of IronRidge, and I'll assume other installers do the same thing, but other racking systems offer the same thing.
Okay, well, just a reminder to the other viewers, we're designing for the biggest wind and biggest snow event of the next 25 years, and
Yeah,
that's a long time.
yeah.
Yeah, I
what-
was just gonna mention, Jay, you're adapting the top plate for the bottom is a little sketchy.
I don't.
Engineering wise, just coming from it as an architect.
Yeah. I don't doubt that. I don't doubt that at all. But I did look and I scoured everything trying to find something that was manufactured that would work. And this was the best I could find. They just don't seem to make those things.
Hey, Jay.
Yeah.
You could actually spray in that great stuff with pest blocking so that you can spray it in the actual pipe itself. And in case that end piece came off, you know, at least you can spray it, but you can use pest block. So that's a suggestion.
Yeah. And I'm sure that would work. I just like, those are only like $4. You can go down at any hardware store. Let's see. I see Nancy Hill. Nancy. I don't think you're Nancy, but you're on mute. Whoop. I see a hand raised, but not getting any sound. Oh, there you go.
That?
There you are.
Can you hear me?
Yeah, yeah.
We're thinking of, we are going to install solar panels at our house on a pergola. And this looks like what we want to do, but ours might be 2 to 4 times larger than this. Would the 3-inch poles be good for that?
In theory, I think the folks are raising some good concerns as far as how are you going to mount them? You know, for the bigger you get, obviously it could become a bigger wind event. I would just I don't want to give you advice before looking at the specific aspect, because that'll just get you and me both in trouble. But you know, if you're going to put it on a concrete pad, you know, that's one thing. These things are normally designed to be buried. You know, the poles go down into the ground. So if you're going to put, like, say, brickwork or something around it after the poles are already set, that might be a better solution, give you a bit more stability. So that's something to consider. I don't know. Do you have a big pad out there already that you want to mount this on?
No, we just have a gravel driveway area, kind of like
Oh, okay.
right now.
Yeah. So you just auger down some big holes and bury these things deeper. That's easy to do. One suggestion I would have for that, if you're going to do it, is when I've done that, you set the poles, then you, of course, you have to make them plumb and let everything set up for a couple of weeks for the concrete to set up properly before you start installing. But then shoot a laser line across and cut the poles off after they're already in place so that you can get them perfectly level. Don't try and cut them before you put them into the ground, because you'll never match, the level exactly right.
That makes total sense.
Yeah. So, but the IronRidge system is a do-it-yourself kind of thing. I mean, that's supposedly how it's marketed. So if you've got some skills, it's something you can do. I mean, it's something I can do. So if I can do it, you can do it. So that's and no animals were hurt in the process of doing this.
Not even human ones.
No, we don't have pictures of there were dogs running around while we were doing this. So.
You're recording this, and I would love to show this to my spouse. How do I see the recording later?
Yeah, we on our YouTube channel, Blue Rock Station, you can go in there and find it. And then on our solarpvtraining.com, we post these under Solar Noon Tuesday. So if you go in there, you'll find the links on solarpvtraining.com, or if you just go into YouTube and search it, either at our site, which is Blue Rock Station, or just look for it by the video name. So
great. Thank you so much.
Sure thing. Yeah, Bill? You're muted too, Bill.
One of the things that's really important to look at is the angle of the slope on the array on these. The foundations and the width of the foundations and the depth of the foundations change dramatically as it goes from 20 degrees up to 30 degrees, 25 degrees. The size is, the more vertical and the steeper the angle on the array, the more it becomes a sail. And so the design specs, and it's fun to play around with a design assistant to look at how that changes. But boy, as you get past 30 degrees, it becomes almost unworkable. I noticed that on your plans here, they were like 18-inch in diameter auger holes. And that's a pretty sizable hole. Most people don't have augers that big.
Yeah, and this particular one, I purposefully left it pretty flat. I think it's got about a 5-degree pitch on there. So snow loading was not a big issue down there in this particular location, but wind is definitely an issue. So I wanted to make it less of an angle. So we'll see in a year if it's still there. We can report back. If it's sailed off over the ridge, we know that we didn't give it enough support. So
Well, you got uplift as well as sideways wind to worry
Yeah.
about. So, yeah, the uplift, that's what your base thing is taking, and hopefully you've grabbed that big concrete thing and that's what's weighting it down. Because with canopies, that's your big load is the uplift from the
Yeah.
wind.
Yeah, that's one of the reasons why those set screws just never have made any sense to me at all, because, it's just so much more secure to just drill right through that pipe and put a big old bolt through there, as opposed to relying on what is essentially surface tension to keep it from sailing off. So, yeah, Nancy, you've raised your hand there.
I'm wondering, every time I see solar arrays, the panels are set close together. What if you leave a 4 or 6 inch gap between them for the wind to go through? Would that be helpful?
I doubt it. I mean, most of the racking systems are designed to clamp 2 panels with a single clamp. There is a little bit of air gap where the bolts are typically, but I don't think whether wind does funny stuff. I think it would act like a wing of an airplane, whether there was a gap there or not. And aesthetically, it would look strange. I think better to just use the way that these things are engineered. They tend to, they have some history there. So,
Jay,
yeah.
I think the ASC C7 is addressing that issue, and it requires a minimum or gap of like 1/4 inch for pressure equalization, which in your case is not an issue because you're like a carport here, but on roofs I'm talking about.
Uh-huh.
And another thing I wanted to maybe throw in here is we've been addressed. We're in Florida. We have this type of carport. We did a lot of them with the galvanized steel, and we have a very high water level here, and sometimes it's just not feasible to use concrete foundations because you can't get beyond like 2.5 foot deep or something. We've been using a method with helical anchors and a coupling that is welded to the foot of the pipe and basically centers itself on the threaded helical anchor. That has been a pretty good concept. It's custom engineered and manufactured here.
Will those helical piers still hold in the sandy soil down there in Florida?
Yeah. Sandy, it depends on where you are. But they're going, you dig basically like a 2 foot deep hole, and then you set the helical anchor, which is another 5 foot. So you have about a 7 foot cone that's deep down. So I don't know the exact numbers, but we can get 15,000 pounds of uplift for each helical anchor.
Mm-hmm. Okay.
So, we had one project it's called Key Waden Island. It's down by Naples, and it's literally right on the Gulf, and I think they're in 170 or 180 mile wind zone, and they insisted on using concrete, and then they were digging down there on that island, and of course they only got like 3 foot deep, and it was all water.
Yeah.
So we ended up going back to ground anchors.
Okay. Well, I know the engineering document on this design said it was rated up to 150 mile per hour wind. So, we'll see. We'll see. Al, I see you had your hand up there.
Yeah, just a quick question. Is this project intended to keep people underneath it dry if it rains?
No. I mean, it's got gaps, between the panels where the bolts are. It keeps you sort of dry unless you're right in the drip line. And I know that they sell those little gasket things that you can stick in where those drip lines are, to help. But these things are so high up anyway that if you get any blowing, you're going to get it blown in on the side. And that became an issue when we were mounting the battery and stuff as well, because all those things under there aren't all NEMA 3R rated for that. So that was an issue. So I think it's that's probably a place where students are going to go smoke cigarettes or something, they're going to, whatever, stay out of the sun. So Tim, you had a question? Yeah, Tim, you're muted, I think. No, now you're muted. You weren't coming through. I'm not getting your sound there. No, I'm still not getting it. We'll get you to work on your technical stuff. Anybody else have anything while Tim's fussing with his machine?
Maybe a little add-on. We had some patio covers just like yours, where we had like, what is it, butyl tape or something applied to the seams, and it does work. It's not 100%, but it achieved the goal of being mostly dry under that cover or patio cover.
Yeah. Okay. Tim, did your sound work? Nope. Okay, sorry about that. Let me jump into the mounting of the panels. If you guys have done a system like this, of course, the first panel is going to take you forever. You know, you want to get that thing properly squared up because everything else is going to key off of that once you work on it. So that's just something that's just part of the install process, getting that first one properly done, which of course we had to mess with for a good long while. And I'll also note, I think I have a better picture of it here when we talk about the wiring. Yeah, we decided the junction box, we used the IronRidge junction box, and this particular junction box for the transition of the cable is not designed to be mounted that way. It's designed to be mounted so it tucks up underneath the panel where those mounts that are showing on the profile of the rail actually mount on top of the rail, and then this snugs up tight to the bottom of the panel. So it's really designed for a rooftop system. But we decided, because this is a classroom thing and we're going to want to get in and demonstrate the connection, that this would work out better if we just simply turned it sideways so that students can come out. We can just flip that panel door open, that junction box door open, and we can look at how the wires are connected in without actually having to get up there and remove the panel and, you know, look at it from the top down. So that was a issue that we did just because this is a demonstration or a classroom type installation. The other thing we ran into, and this is just, it was 100% my fault, but these panels, I had never used the panels that had like the positive and the negative on two different sides of the panel. Normally they're in a single box at the top or the bottom. I guess this is becoming more prevalent. And we did not think about it when we were putting all the panels down, that we had to make sure the positive and the negative connection points were in the right orientation for all of our daisy chain wiring by the time we were done. So after we got our last panel up there, then we're starting to look at the connectors going, oh, two negatives are together and two positives are together. And it's like, really, guys? Okay, let's get back up there and let's start flipping panels around. You know, it's that. It usually on a rooftop system, the dumb thing that I do each time is like with end-phase inverters, you forget to record which inverter is in which location until after you've set all of your panels in place. And then you got to go back and lift all the panels back off to get the serial numbers off of the inverters and all of that. And that's usually the dumb thing that I do near the end of the install. Well, this was the dumb thing that I did this time, which was not orienting the panels properly. So that was, so if you're doing this, bear in mind, it matters where the positive and the negative leads are as you're going to hook these things together. And I guess while I've got this picture up here, you can see these spotlights that are right here at the end of that pole. Those, we have these two really nice spotlights that are designed to shoot on the flagpole that's nearby. And it's got a photosensitive switch there so that when it gets dark, these things will kick on, and when it gets light, they'll turn off. So we've got a 5 kW system to run two lights. So that's, like I said, overkill. Then we got into the hanging of the inverter and the battery. And my original thought on this when I was designing it is I got a couple of NEMA 3 cases and I made sure they were the right size for the product. And I thought, all right, well, we'll just bolt it to the pad, and then we'll bolt the battery will be on the bottom, the inverter will be on the top, and we'll just run the things through the boxes and everything will be contained. And then we started looking at the product once we got there. And first off, all of the entrance, all of the connections have to come in through the bottoms of these units. So trying to do it the way I had designed it was not going to work, because all of the wire entrances were going to be through the bottom of the boxes. So these things are pretty much designed to hang on walls. That was how it was, not to be in a box, because you have to access these ports at the bottom of the unit. So we fussed around a little bit, and Jimmy really came up with the idea of getting this unistrut and mounting it across between these poles. So that gives us at least two sides here with lateral cross bracing, right? Sort of. So anyway, so the unistrut goes across there, and the Sol-Ark inverter is NEMA 3R rated. So it's rated for outdoor conditions, but the lithium ion battery there is not. So, so that became somewhat problematic. So what we did is we took one of these cases and we mounted it to the unistrut. But then as we were measuring everything, the battery, which is at his feet there, is the right size to go into this box. But again, all of the connections go through the bottom of it. So what we ended up doing is cutting the bottom out of this box and then putting the mounting bracket there to hang the battery within this case to protect it from the elements, but still have access to all of the ports. So my worry with this particular thing is now we've created a perfect place for hornets' nests and whatever other critters decide they want to fly up in there, but that'll just be something that you've got to monitor. So I guess you can see that it ends up, the wires are looping back here. We put a couple of outlets there. I think I've got some pictures there. Now, when you go to hook this thing up, connecting in the battery to the inverter, it looks pretty complicated when you're looking at the wiring diagrams that come with the unit. So if somebody was doing this as a do-it-yourself, and you would just look at it and probably freak out. But there's a lot of functionality to these systems that we were not using. So really the bottom line is it came down to, we've got three things to hook into. You know, we've got the PV strings, and right there in the center, you can see there's PV plus, PV minus. They're just those little flip tab connectors, and it'll take, I think, up to 4 strings into this unit. So we were only bringing in 1 string. So we just had to come in with the positive and the negative wire there. To the right in that terminal block, you've got the grid, the load, or the generator, the load, and the grid. We're only using the load. So we just had to hook out of there with line 1, neutral, and ground to our loads, because we're not hooking it into the grid. We're not hooking in a generator. And then the other connection was up there in the upper left, which was the batteries. So positive and negative ports for the batteries. So you're just hooking in the batteries, hooking in the PV array, and hooking in your loads. Pretty straightforward there. It might be more complicated because we haven't actually got it working yet. But yeah, there's somebody's, is this grounded? And the answer is yes. The way that we did it, normally it would be grounded through the service panel. You know, you would run your loads connecting to the grid, and then it would be grounded through the service panel. What we did here is, I think this next one, yeah, you can see we use this AC disconnect almost like it was a service panel, where we went ahead and put the ground there and then ran down to the ground rod from that AC disconnect. So, and we also bonded the neutral to the ground in the AC disconnect, just as it would have been done in a service panel. So we basically treated this AC disconnect as a service panel and made our grounding connection there. So, and then there's a ground wire that runs down from that. Of course, the unit itself is all bonded together, but we've got a ground going down to the ground rod. So that'll give you that sense there. And then this was our big load, which shines up on the spotlight. And then you can see this solar flagpole. And this solar flagpole was a project that they put in there at the college, and it's part of their solar thing, but it's supposed to be solar lit. And if you look at the base of the pole, there's a tiny little panel. It's like a 50 watt or 25 watt panel, and a ring of LED lights right above it. And that's supposed to be the whole lighting thing for that flagpole. So when it's operating, you get about 5 feet of light going up the panel, up the pole, with no light actually making it to the flag. So that was kind of useless. So what we've done here is put this spotlight, and hopefully that's gonna provide some light. I don't know how that thing's supposed to work. Maybe, I can't imagine. No, I mean, they installed it right. It's just not designed properly, that flagpole, and it's not cheap. So, and now comes the commissioning. So I guess my question to you guys, anybody commission one of these systems ever? Do you know what, because when we turned the whole thing on, it just said you don't have a battery, and some alarm was going off and everything. And we just turned everything off and said, we'll deal with it later. So, let's see, did some concrete plunder's bench. All right. I can see that we're over our time. I'm seeing questions jumping in, but anyway, I didn't mean to run so long, but I appreciate everybody's attention, and we'll see you guys next week. I'll try and do this from the ACES conference next week, so we'll see how that works out. All right. So thank you,
Thanks,
everybody.
Jay.
See you later. Bye-bye.